Okay, I'm just going to spend a few minutes here giving some practical demonstration of raku Dan, some data analytics demo examples. Just to let you know how I'm running this. Basically running right now an AWS Light sale. First 3 months are free. I use a free micro server, and just very simple to specify the container that I want to run. So this container P60 raku Dan Jupyter blah 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 is on the Docker Hub, so you can call it whatever you want. Put this image in here. Make sure you put launch.sh and 8888, and you're off to the races. That's all described in the raku Dan Jupyter GitHub README if you want to refer to that later. When you're up and running, you can click this link and that opens a tab directly into the Jupyter console. Just one thing I would say is to do that, first time you have to log in, and you'll need a token for that, because when the command, the launch shell command runs, it runs a token. So we'll look in the logs here and search for token, and here it is. We just pick this up if we're required to put a token. This stays in the logs for about a day, so if you want to use it for multiple days, which is fine, you just have to remember the token if you lose the cookie in your browser. Okay, fine. So here we sit in Jupyter console. So Jupyter's historically a Python environment with a Python kernel, but thanks to the work of Brian Duggan, there's actually a raku Jupyter kernel, and that's what we're running here. Very easy, just create a new one, and here we've got some that are existing examples as part of the raku Dan Jupyter module that you can load up, and you can make changes and do anything you want with these. It's really cool to experiment. So if you haven't seen the way that Jupyter works before, it's a set of cells, and you run them one at a time. So I'm just going to run, I already ran the first one, I'm just going to run the second one here. And what that does is it's a reading in using text CSV module to read in a CSV file. That's pretty cool, because there's a lot of potential gotchas in CSV file reading, like quotations and reuse of the comma for, in the actual text and so forth. So that stamps all those out. There's a little ROC compliance here, so read the text at your leisure. So then I'm going to make a new data frame called stats. Going to feed it the first line as the column labels and all the other lines. So this is obviously a positional accessor slice from line 1 to the last line. N is the number of elements, so elements minus 1. And then I have the equivalent here in raku Dan for the Python pandas head, which is stats row 0 through 5. And there we have it. So this is the data that we just read in from the CSV in a standard data frame format. There's other ways to read stuff in, so you don't have to use text CSV. This is so you can do it with a regex, for example. Just shows you how. And then when I've got that, then I can run another cell. This is going to give me the tail equivalent, so it's from end less 5 to end less 1. So it's the last 5 elements. And just to clarify here, the little tilde here makes a string. So you get a string output rather than an object output. And the caret, this is a specific exported postfix function. So basically, when I access, let's look at something. Okay, let's put in a new cell. It's a really a live demo. So with cascading accessors, I can put in an accessor. It's a 2-dimensional accessor that's going to pick out the country code. So that's this thing here, right? Row 1, column 1. The reason I need so if I actually want to get a set of rows, then that gets returned to me from this single dimension accessor as a list of data slices. So the purpose of the caret here is to reassemble that list of data slices into a new data frame. So that's what you're seeing here in the output display, is a data frame that's been created on the fly, just for purposes of display. Okay, so I can look at the shape, number of elements, number of columns. I can do some tidy up things. So here we've got the columns is, as I mentioned in the presentation, it's just a hash. It's just a raku hash as an attribute, and the value of the hash is the index number of the column. So since hashes are unordered, you get them unordered like this. You can actually write with the columns method, but then you have to write a little zip with the pair operator here to interleave in the numbers, the index numbers. So that's how you do that. And then stat.cx is kind of a handy shortcut to give you the column names in the right order based on the value. I can do other kinds of cleanup, so I can coerce columns to numbers, and then I use dtypes function that will tell you what the types are in each of the columns, and I can use stats describe, and that's going to tell you a whole bunch of stats about the numeric columns. And count, mean, standard deviation, the 5 quadrants also shown here. So this is something very familiar if you're using Python pandas. Just to touch on it, some other things in here, I can calculate and append a new column using the stat splice function. I can, what else can I do? I can do clever accessors with reverse order, or every 20th item. I can grep out as a filter to match certain stuff and so on. Not enough time to go into all that. All right. So that gives you an idea of the pure raku Dan functionality. Now let's look at using Dan with Dan pandas together. So this time I don't use the all because I want my data frame to be a Dan pandas data frame. Okay, let's just do that. So I'm reading in the same CSV, same way. So Dan pandas is kind of a sister library module that has the same functionality as Dan. So Dan is kind of the standard API, and Dan pandas implements the API, but in doing so, it creates a shadow data frame over it as a Python pandas data frame. So it's just using Dan as the API to access that. So you can reuse all those capabilities like the slice accessors, the caret, and so on. So is it really a Dan pandas data frame? Yes, it is. So I can do the tail as well. I can do the shape, the elements, and so on. Okay, cool. So there's also in here, just keep banging through, a stats PD. So this is basically the way that you run a pandas method on a Dan pandas data frame is with a PD, and then you give it a string, which is the thing you want it to do that you would normally do in pandas. So this gets run as a pandas string in Python using inline Python behind the scenes. But apart from that, everything is pretty much the same. And there's ways to store and import both the raku Dan can save as the raku Dan pandas data frame, both those variants. Okay, I'm just finishing up now in raku Dan pandas side of things. The last thing I want to do is the cell here, which exports the data frame that I made and cleaned for use in a plot environment. So here again, I'm using the PD syntax to just put in a Python pandas call to save that shadow data frame that I've been working on as a JSON file. And here it is up here, stored away about a minute ago. Cool. So next I go over to my Dan to pandas Seaborn demo workbook here. So this is basically illustrating how to do a hybrid workflow, for example, using raku Dan for data acquisition and cleansing. And actually raku is great for that with the regex, second generation regexes, with grammars, with true Unicode support. I would think that Raku could solve a lot of quite thorny data acquisition and cleansing issues. And we can talk a little bit about types shortly as well. So when I've done that, I can then use Raku Dan pandas to export over, as we just saw. And then I'm using Python pandas here to read the JSON. So I just have to load it, import matplotlib and the various incantations for that. I'm going to read the file. You can see my cells are just going through one by one. I'm going to print it out just with stats. And then I'm going to hit the first seaborn plot, which is distribution statistics of internet users. I'm going to do a box plot for the the various numeric columns. So all the the richness of the seaborn. Here's a some things from the gallery, some LM plot. So some kind of distribution over 2 dimensions. Here's a different one with labeled by the income group, so you can use labels in the seaborn way, and see what this last one does. Okay, again using labels there. So the full richness of matplotlib and seaborn is available. Even if you're using Raku for your data framework initially. Cool. Okay, and then last thing I wanted to do was to look at something that is particular and unique to Raku. So this is using Raku Dan to use Raku type system in the context of the Raku Dan data frames. So let's read it in again. So let's say I want to clean up my data prior to analyzing. So first of all, we looked at how we can. By the way, you can have little markdown cells in here to describe what's going on. You can create this as kind of a learning tool as well, and create notebooks of your own and so on. So I'm going to clean up my columns as we've done before. And now let's look at my data types. So remember, I haven't actually done the coercion to rats here. Oh shoot! These birth rate and internet user numbers, I can see them in my overview print here. They've come out as strings. What's going on here? Well, they were stored as strings in that original CSV, and in Raku, the default behavior is to keep those as strings, and you can go ahead in Raku and use string types as numbers anytime you want. So an example of that, I haven't touched any of these types here, but I can apply the add reduce, square brackets, a reduce operator. So here I'm going to add all the values in my birth rate column. Remember, that's the 2-dimensional accessor. In this case, you can use a associative, a label accessor in these angle brackets, and that might be fine. That might be, so I can add them up. So I better do it and run it. Okay. And my birth rate's on at 4,146. So all those strings, Raku just happily uses those in a mathematical operation, and Bob's your uncle. So that might be fine for you. You might just be doing some prototyping. You don't care. So, why do parsing? It just works. But you don't want to get to a point down the road. Maybe you sent your results to a colleague, and a data entry will not convert due to a transposition error. Let's say you have something like 26 lambda 4 as a number. Well, it's not a number, is it? It's fine as a string, but that'll throw an error when you try and add it. And also you might want to already control the data types, such as for being more efficient in how you store or process number representations earlier on in the process. So how can you check the type of your data and coerce it into the way you want it? So here I'm going to do a different approach now. You've seen it a little bit before, and this is really describing what's going on. So you'll be familiar now by saying with the data I'm going to map. Basically, you have to pick up the data data table within the data frame if you're going to modify the elements. So here I'm walking across my data, and I'm mapping everything in column 3. And column 2, so column 2 and column 3, these are my numeric columns, and mapping them over to a rat. So that's basically saying for each one, take the item and apply the rat method to each item and then put the result back in. That's the dot equals. Can apply method, put the result back in raku. And now I can use something which is a relatively new feature raku, which says, give me a list. This is just a standard. This R is just a standard raku function now. Give me a list, and I'm going to tell you what the the lowest common denominator type is. So if everything's an int, it will give me an int. If everything's if there's a mix of rats and ints, it will give me a numeric, and so on. So in this case, I've made everything a rat, so it gives me a rat back for that. So that's cool. So raku is gradually typed. So I can use these types when and where I want them, but otherwise they're out of the way. So I can put, depending on what I want in my columns, I can make it so using these coercion mappings. Okay, cool. So now, how do I control Dan type? What I've got, and how can I use raku types in the equation here? So it's dead easy. So first of all, I can, I have this type called series, which is my Dan series. So each column is a series. So when I look at my data frame, if I look at it, if I access it as data frame, everything in that column called country name, that will give me the series back. And I want to check that that is a particular kind of series. So I can define a subset of series. Let's say it's a rat series where all my data are rats, or a string series where all my data are strings. So with these subsets, I can be as creative as I like. There could be a min-max. There could be, I can rewrite stuff, by picking out things that don't match, and then rewrite them, coercing selectively depending on the value. For example, I might want to make things that are out of range a nan, and that would be a straightforward thing to do, because I can very easily tell whether they're a string or not, or a rat or not. Okay, so I might want to test for that. So that's all built into the raku syntax. Subset rat series, subset string series, and then I can just create a subset data frame, so a demographic data frame of my standard Dan data frame, where each of my columns have specific types. So these are just a set of tests which are added together to check that everything I've got is correct. And you might have an alternate form of that where you don't care about the column label, but here I'm also checking by that my column labels have been tidied up too. So let's just define those guys. Yep, so they're defined now. And then finally, I can start to use those types in my code. So for example, I might decide to have a new variable, demo data frame, which applies those checks before I can store stats in that variable. So now I'm making a typed variable, or I can put the check into a function signature. So here I've got a function print dft where I'm checking I've got the right kind of demo data frame, and it's defined every time I call that function. So you can see here we're just using the standard raku type tools to apply very powerful type checking and type controls around the Dan data frames. And that's something that absolutely doesn't exist in Python. There's a few type hint modules, but they will not apply at this data frame type level. So very powerful way to control what is being sent around in terms of the validation and different workflow stages, particularly those key handoff points. And also it's a debugging tool. If I can't get my my data frame to basically converge in a good way, I can look at what do I got, and why is that therefore out of whack, and how can I fix it. Very interesting and exciting new capabilities when you start to bring the data frame concepts and the core raku concepts together. So that's it today for the demo, and we'll go back to the main presentation.